Okay, kids, it's time for the sequel. So part two of this big, large lesson on trig functions, specifically the 6 trig ratios. So we're going to look at using calculators today. Normally calculators seem like they make your life easier. I actually think they make your life quite a bit more difficult. With special angles, you can just say things like, okay, well, if I've got this sort of thing, 1/2 or whatever, I can say I've got a 30-degree angle, or I can say it's pi/6. But when you have something that's non-special, so this is basically anything other than, so like not 0, 30, 45, 60, 90, or anything that's coterminal to those angles, then we're going to have to be thinking about using a calculator. So a few things you should just know about your calculator. First of all, we should know this from grade 10. If you want to get the angle, you have to use inverse, so inverse sine or inverse cosine or whatever. Keep in mind that whatever mode your calculator is in, radians or degrees, it's going to spit the answer back out as radians or degrees. So if your calculator is in, let's just check what mode mine's in. I'm in degree mode. Then that means if I go inverse sine of, and I'm just going to use something like 1/2, so 1 divided by 2, and if I push equals, I'm going to get 30, which is 30 degrees. And if I have it in radian mode, then what I'm going to get is I'm going to get myself something similar. Well, similar equation to type in. I'm going to get a totally different answer. So this one is radians. Now, of course, if you're wondering why it's such a weird number, remember that in my example here, I'm saying sine of inverse sine of 1/2. So what I'm doing here is I'm thinking about this special angle just because it's familiar. This is 30 degrees, or it's pi/6, depending on radians or degrees. And pi divided by 6 is 0.523. Okay, so your calculator is probably not going to spit out pi divided by 6 unless you've got one of those fancy ones, and I know some do. But this one, it's useful to just sort of recognize some stuff. Anyway, just make sure you're in the right mode. Okay, calculators generally don't have cosecant, secant, and cotan buttons. So if you're going to solve something like this reciprocal ratio, cosecant theta equals 2, what you've got to do is you've actually got to turn it into sine. And the way you do that is you take the ratio and you flip it. So instead of this, you're going to think of it as 2/1, and then you're going to wind up flipping it, okay? So this is what we have to do, because you cannot just simply go inverse inverse cosecant. I don't have that button on my calculator. This doesn't exist on mine, and it probably doesn't exist on yours, okay? So if we're ever solving for the reciprocal ratios, you have to write them as their corresponding primary ratio, and you do that by flipping the actual ratio. Okay, now when we're solving with calculators, keep in mind that in one rotation, so I'm talking about around the Cartesian coordinate system here, usually we'll have two angles that have the same trig ratio, like for example 30 and 150 would have the same sine ratio, right? We'd say sine of 30 equals sine of 150. And they're both equal to 1/2. So if we ever go inverse sine of 1/2, our calculator is going to give us 30 degrees, but we also have to understand, also that 150 exists. Now your calculator is always going to solve for the closest angle to the positive x-axis. It's not necessarily going to give you the reference angle all the time. It gives you the closest angle to the positive x-axis. So sometimes that will be the reference angle, but sometimes it will not, and it depends on what you put into your calculator. For example, if I wanted to go theta equals inverse tan of, let's see, 1/, I don't know, I'm just sort of making something up here, opposite over Jason 1/10, something like that. If I actually type that in on my calculator and I went inverse tan of 1/10, what it will do is it will give me a positive quantity, which is a pretty small angle, and that's because what it's interpreting is it's saying, okay, well, to have a ratio of 1/10, that could be in quadrant 1 or it could be in quadrant 3, right? Because tan is positive in 1 and 3. So it gives me It could give me this one, or it could give me this one, but it gives me this one here because it's the closest to the positive x-axis. If I was to go and I was to type in inverse tan of negative 1 over 10, and I push equals, then it's going to give me the negative angle, because the negative angle would be down here, and it's the closest one. It could have also been up here as well. So these are the positive angles, these are the negative angles. So anyway, when it has a choice of two different angles, which it always does, it always gives you the closest ones to the positive x-axis. Now this can all get a little bit confusing here. So what I would advise you is, when you are using your calculator and you're doing inverse, you should ignore negative signs when you're taking the inverse. So if you have to solve, let's say you have to solve tan theta equals negative 1 over 10, I would always convert to positive, and I would always type in inverse tan of 1 over 10, not negative 1 over 10. So ignore that one. If you do that, you will always be taking the inverse trig ratio on a positive quantity, and you're always going to get the reference angle. It's always going to give you that quadrant 1 angle there, which will be the actual reference angle. And like I just sort of mentioned before, if you keep the negative sign in there, it's going to give you your weird quadrant 4 angle, and trust me, things can get confusing. It's not impossible to make sense of, but it can get confusing. Anyway, okay, I hope that all made sense. I think I started to ramble a little bit, but let's look at an example here. So we're on to example 5 because this part 2 is the same note. So if we were going to solve tan theta equals negative 1.2, the first thing I'd like to do is I'd like to just take a second think about this, because it's really easy to do trig without really understanding anything just by pushing buttons on the calculator. Let's actually think about this. So this is saying I have a triangle. What angle has a corresponding ratio of opposite over adjacent of negative 1.2? So first of all, negative doesn't make a lot of sense when you're thinking about just triangles, so I'm going to think about this in terms of positives. Opposite over adjacent, a ratio of 1.2. That means that the opposite is a little bit bigger than the adjacent. So the opposite might be 1.2 and the adjacent might be 1. Or it could be some other ratio. It could be 6 over 5. It doesn't really matter. But what I'm expecting here is I'm going to get some angle, and I bet you my angle is going to be somewhere in the ballpark of maybe 50 or 60 degrees. Okay, it's really good to have this in your brain somewhere. Now, of course, what this negative sign actually means is it means that we still have the same triangle, but it's got to be in quadrants 2 or 4, right? Because all students take calculus. If it's negative, it's in quadrants 2 or 4, so chances are it's looking more like this, or it's looking more like this, which means my angles are actually going to be larger than 90, or they're going to spin and be almost 360. Now, all of that's not important to write down every single time, but I really hope you take a second, just appreciate what we're doing here in trigonometry, because it's super easy to just kind of forget about what we're actually doing. Okay, so there's 2 ways of doing this. Now, the way that I would highly recommend is I would go inverse tan, and like I was saying before, I would ignore the negative sign. So I would get 1.2, and I'm actually going to write here, this is going to give me my reference angle. So again, just to make it super 100% clear, I'm going to write a little tiny note. I'm going to say reference angle is obtained by ignoring the negative sign on the opposite over adjacent. So we're going to find the reference angle by going inverse tan of 1.2. Now, I can see here that this is talking about degrees, so I'm going to think the context of my question is to have everything in degree mode. So I'm going to go to my calculator. I'm going to make sure I put it in degree mode, otherwise I'm going to get real confused. I'm going to go inverse tan of 1.2. When I do this, I get 50.19 degrees. Okay, so that's about roughly what I expected given the ratio of opposite to adjacent. The opposite is a tiny bit bigger than the adjacent because the ratio is a bit bigger than 1.2. So that's my reference angle. Now, of course, this negative sign, what this does is this tells me tan is negative in quadrant 2 and quadrant 4. So in quadrant 2, my actual angle equals 180 minus the reference angle. So that's equal to 180 minus 50.19, and that gives me 129.81 degrees. And in quadrant 4, theta is equal to 360. I should put the degree symbols up there. Minus the reference angle, which is 360 minus 50.19, which will be 309.81. Cool, okay. And that's actually just about, oh, okay, my pen's going weird. That's actually just about it. Now, when I came up with this example, I wanted to show what would happen if you did not ignore the negative sign. So this is a slightly alternative way. If you choose to ignore the negative, or sorry, to not ignore it, if you choose to not ignore the negative sign, when you go theta and you go inverse tan and you do negative 1.2, what's going to wind up happening here is you're going to go inverse tan, but you're going to go negative 1.2. If you do it that way, your calculator is going to spit out an answer of negative 50.19 degrees. So the thing you must appreciate about this is that is the correct answer. This is actually coterminal with, my writing's getting extra worse, 309.81, right? Because what we have here is you can spin around this way, and that's 309.81, or you can go this way, and that's negative 50.19. You actually get the same answer, and that is a correct answer, but this is out of domain. But out of the domain. And then we have another issue here, and then we go, okay, how to calculate the quadrant 2 angle. So we get used to some things here. Okay, this isn't Spanish. We don't have to put question marks on either side. So we're used to some formulas that are familiar, like theta equals 180 minus reference angle. That's how you can get the quadrant 2 angle. If you start doing negative angles, I don't even know what the formulas would look like. I'd have to actually think about it. And I don't necessarily want to think about it. I want to do things that are familiar, okay? So I'm going to advise you not to do this. I would, so I'm just going to finally put not recommended. Okay, anyway, I hope I've made my point. Ignore the negative sign whenever you're using your calculator. And you'll notice you don't have these issues when you're doing special angles because you're not even using your calculator, you're just thinking about it. Okay, so let's look at another one. If you have not done anything, you should pause the video and do it. But actually do it. Actually pause the video. I know you're waiting for me to continue, but you should actually pause the video. Now, if you did pause the video the first time, I'm very proud of you. If you still haven't paused it, I'm just so disappointed in you. Don't make me disappointed in you. Okay, so we're going to solve this now. Okay, so just looking at the domain restriction here, the context is in radians. So when we solve this, we're going to go inverse cos, and we're going to go 0.27. I'm not actually going to include the negative. I'm going to write a tiny little note here. Come on, computer. So 2 notes. Okay, radian mode, and ignore the negative. So what we're going to do is we're going to make sure our calculator is in radian mode. Why do I have to click on everything 3 times? Come on, computer. Okay, so we're going to go mode. We're going to go down to radian mode. Is it annoying changing your calculator from mode to mode? You betcha. Do you have to do it? You betcha. So we're going to go to 0.27. Before we just go nuts, let's just take a second, think about this. What does a cosine ratio of 0.27 mean? That's the ratio of adjacent over hypotenuse. So an example of a triangle might look something like, nope, it's not going to look like that. the adjacent would be like 1 and the hypotenuse might be 4, because that's about 1 over 4, which is about 0.27. So this is what it might look like. I bet you we're going to get an angle of maybe 70 degrees. Since we're in radians, oh geez, what is that going to be? Pi over 3 maybe? Anyway, let's push equals and see what happens. Okay, my calculator is not going to give me pi over 3, but it gave me 1.297. This can be pretty scary. So by the way, this is the reference angle calculation here. So this is reference angle, 1.2974. Okay, this is not pi. This has nothing to do with pi, but you can think in terms of pi. Remember, pi equals 3.14 approximately. I guess that's approximate. Pi over 2 is approximately 1.57. So this is, this is maybe not quite 90 degrees, but that sort of makes sense. That might be like 70 degrees or something like that. Anyway, we get this weird reference angle in terms of radians, and it's 1.29 radians. So keep in mind, 1 radian is about 57 degrees. All right, anyway, we're just trying to make sense of things. And I keep repeating this just because in my experience, people really have a tendency in this unit to just kind of forget what they're actually doing, and they get kind of confused with radians and degrees and switching. And when they don't see a pi, they get upset and all that sort of stuff. Okay. Anyway, so let's look at this. We go back to the original. We say there's a negative sign. So in what quadrants is cosine negative? It's negative in quadrants 2 and 3. Remember, A, S, T, C. So it's quadrants 2 and 3. Okay, so a reference angle in quadrant 2 and a reference angle in quadrant 3. So in quadrant 2, now we do have to be careful because see our domain restriction, we're not allowed to go further than pi. So we can go up to quadrant 2, we can go all the way this way, but we can't go past pi. So if we want to go to quadrant 3, we got to go this way. So in quadrant 2, this is easy. This is, I shouldn't put my equal signs there quite yet. In quadrant 2, theta equals 1. Let's not go 180. Let's go pi because we're talking about radians. Okay, so this is pi minus, and this is an uncomfortable feeling because you want to have something in terms of pi, but guess what? It's pi minus 1.2974. So on our calculator here, we're going to go pi minus the answer. And just sort of curiosity, if you're wondering, no, this part doesn't matter for degrees or radians because we're just multiplying some numbers. Sorry, we're just subtracting some numbers, but we're just doing number arithmetic here. Okay, so 1.844, and you could write radians if you want, if that makes you feel more comfortable. Because I don't see a pi, I might actually recommend doing radians here, so we'll just write rad. Cool. Okay, quadrant 3. How are we going to work out quadrant 3? What we know here is we've got 2 angles, and we know we've got the reference angles. What I personally would do is I actually have to think about this a teeny little bit. I would say our angle is going to be the negative version of this. So if we're talking about negative angles, we can use this exact same formula, I guess I'll call it, and we can put a negative sign out in front. Common sense might even tell you you're going to wind up getting just the negative version of this. As I've mentioned a few times, I'm not a big fan of memorizing formulas. I'm a big fan of thinking about things, and I can see that there's some symmetry here. So I'll write a tiny little note here, and I got to click on this a bunch of times. I'll write a tiny little note. We can simply put a minus sign for negative angles. But again, you should definitely think about why that is instead of just listening. Cool. Okay, so we've got our values, and the question said round to 2 decimal places, so I'm just going to make one correction. I'm going to delete that little 4. I'm going to delete that little 4. Okay, there we go. Now everyone's happy, and I'm going to make sure I get my right color here. And I don't know why I have to click on that so much. Okay. Here's one, cotan, same thing. I would highly recommend you take a sec and you try and do this yourself. Well, let's give it a go. So the first thing you do is you recognize that this is a reciprocal ratio, and you cannot solve this. So what you have to convert this into is tan theta equals 1 over 4.3. Congratulations, you've just changed this into an equivalent thing that we can solve. So to get the reference angle, we're going to go inverse tan of 1 over 4.3. And again, this is radian mode, rad mode. So we go to calculator. I believe we are still in radian mode, and we go inverse tan of 1 divided by 4.3. And we get ourselves 0.228. So for whatever that is worth, I'll even take one more decimal place. I like to take a couple extras. Okay, so that is 0.2285, and just kind of to keep it in your brain, what did you actually solve for? 0.2285 radians is approximately equal to, well, if 1 radian is approximately 57 degrees, this is a little less than a quarter, so this might be like, I don't know, I'm going to ballpark a little less than a quarter. 57 might be like 12 degrees, just to kind of have it in your mind. Okay. And we can see that we are positive, so tan is positive in quadrants 1 and quadrant 3. So cotan is also positive in quadrant 1 and quadrant 3. So this is going to turn into my quadrant 1 angle. Theta equals theta reference. It's very simple. So 0.2285. And then in quadrant 3, theta equals 180 or pi plus the reference angle, because we're going around, here's pi, and then we're adding to it the reference angle. So that's going to be pi plus 0.2285, which is equal to, I guess I'll go second pi plus, and then I'll use the answer key here, and I'll get myself 3.37. 3.37 with some zeros. Now I notice here that I cannot, rats, so I actually notice I cannot go past pi. So what I did is I went past pi, rotating in the positive direction. So this is not actually going to be good. My bad, I should have looked at that before. So let's actually get rid of this. I'm not going to erase it because I think it's worth keeping. But this is past pi, so out of the domain. So if I want to get to quadrant 3 without going past pi, I'm going to have to spin around the other direction. So what I can do is I'm going to go theta equals, and I can see that if I spin around here, I can go pi and I can subtract the reference angle. And that's actually going to get me the negative quantity. So the angle I'm going in reverse is I'm going, see, you can really confuse yourself with a lot of negatives. I would do it this way. I'd put a negative sign in front and I'd go pi minus the reference angle. I know I'm going pi, and then I'm going pi, then I'm subtracting the reference angle, and then it's got to be a negative quantity, so I just have that sign out in front. Another way you could do it is you could actually go reference angle minus pi, but I don't like that. Okay, so anyways, this is going to be negative, and then I just about wrote 3.14, but I'll just write negative pi minus 0.2285. So that's going to give me, so negative sign in front, and then I'm going to close this up, and then I've got negative 2.91. That's probably fine. Do I need to go any further? Okay, so one other thing here is I've got this lower restriction, which means I can spin all the way around, all the way to negative 2 pi. So my quadrant 1 angle, I'm actually going to wind up hitting a second time. So what I need to do is I also need to work this one out. So I figured it out as a positive angle, which is right here, I figured out a negative angle in quadrant 3, but I also need to work out going, and let's just put a little note here. I rotated, also rotating in the negative direction. So here's the thing, how am I going to work this one out? How do I figure out this angle? So the concept should hopefully not be too tricky here. I spin and I rotate all the way around up to negative 2 pi. So what I can say here is I'm going negative 2 pi and then I'm backing up the reference angle here. So there's my little reference angle. So it would make sense if I had negative 2 pi and I actually removed from it 0.2285. So you could go negative 2 pi minus negative 0.2285. I think that's really confusing. What I would simply do is I would think in terms of just the numbers. I've got 2 pi, I'm subtracting my reference angle, but the thing's got to be negative because I rotated in the negative direction. So it's going to be negative 2 pi minus the reference angle. Okay, so this is going to be negative here, and that's going to be negative, I guess I need my calculator for this one, 2 second pi. I'm going to take away 0.2285. I'm going to get my value of 6.05, but I'm going to make it negative 6.05. All right, so there we go. And I'm going to round this to 2 decimal places because I believe that's what I had in the beginning. Yes, I did. So finally, therefore, theta equals, starting with the smallest one, 0.06, negative 6.05. I'll get it out one of these days. Negative 2.91 and 0.23. Those would be my 3 angles. Anyway, I hope that all makes sense. This would be a great time if we were in class for people to sit there and raise their hand, because normally people get a little confused, and I actually don't blame them when we're dealing with negative angles, rotating in different quadrants. It can get pretty tricky. You definitely have to think pretty hard about it. Now, if you're looking for a way of solving this, what I might recommend here is I'm going to go grab a okay, well, I'd really prefer if people weren't staring at my email. I'm going to go, and I'm going to go to Wolfram Alpha. So we're going to go there, and we're going to actually just take a sec. I know I was saying calculators can't solve this for you, but I bet you Wolfram Alpha can. So if we want to solve something like, what was it, cotan x equals 4.3, we might even be able to do in the domain negative 2 pi x pi. Would it understand this? I actually have no idea if it will fully understand, but let's see if this works. So cotan there, negative 2 pi to pi, and it winds up giving us, it plotted it, but it didn't solve it for us. But I can see we've got some intersection points here, so I'm actually a little surprised it didn't solve it and give us some answers, but it plotted it. Anyway, we can see that one of my things here is just to the left of negative 6, so that's good. One of them is at about negative, we're going to ballpark that at maybe like negative 3, and then one is just a tiny bit bigger than 0. So does that correspond with the answers that I actually got? And I got myself negative 6, negative, okay, that's close to 3, and 0.23, so I think that actually works. So it's interesting that Wolfram Alpha understood what I was saying, except it just wanted me to plot it instead of solve it. I'm sure if I erased this, it probably would have solved it a little better. Okay, anyway, it gives you one of those generic answers, which is probably not very helpful right now. Okay, moving on. Well, I say moving on, but that's it. Well, okay. So anyway, I was excited for some more math, but I guess that's all there is. So how do we conclude this whole thing? I will say you definitely want some practice with this. If there's anything in math that requires practice, it's these types of questions. They make a lot of sense, and most people have no trouble getting the reference angles. It's just dealing with those negative angles and the quadrants and all that. So we'll leave it there. And as always, if people wind up having questions, I am available. We'll see you on the next video. Well, maybe I won't see you, but you'll see me in my beautiful bald head. Goodbye, everyone.